You are doing so great for following every lesson in data science class. And the reason we will have to do this is at some point in the data science lessons, we'll have to create our own functions to train data and do other stuff. Okay, so yeah, this lesson is going to focus on creating your own function and then specifying what you want to happen, what you want to do in that function. Okay, so to create a function, you need a def or def keyword and the name of the function plus colon. So I have it here. You need the def, which is called the define, and the name of the function. So we want to create a greeting function, and I want to call it greet. Okay, together with a colon. So I mean, at some point you will pass some stuff in the parentheses or the bracket in there. But for now, let's say I'll just need only these. Then we then pass what we wish to see when the function is being called. So what I mean by pass is that I come here and I'll write whatever I want to see when we call the greet function. Okay, so I mean this follows the for loop and the while loop that we've been doing, and then the if statement so far. So I think you'll be able to understand this process with that. And this greet or everything that is in that side from this side going right where the cursor is blinking is what would define this function. Okay, we focus on creating a function and using the return key in this lesson. So in some other lessons we do more advanced features in the function. Okay, so here I want to create a greeting function that if I call that, it will just greet you and say hey. So when I call the greeting function, I want Python, or I want to be able to see this hello, right? I want to say hello, welcome to Python functions. Okay, this is Python functions. Right, so this is a greeting function that I'm creating. So I'm done that. If I call this greeting, so let me run this code for it to so when I run it, I'll define that function. Okay, now if I call the greet function, what we wish to see is the hello welcome to Python function. Okay, so see that if I call this greet function, I have to call the way the function is being designed. All right, it has just greet and parentheses and nothing else. Okay, so if I call this function, it prints hello welcome to Python functions. Okay, so this is what functions are used for, or that's one of the usefulness of functions. You define something, you define a particular function name, then you type in whatever you want to see when that function is being called. Normally is the function is actually important when you have to create a particular block of code or some other things multiple times. Then you can use the function to just define it once, and then wherever it is needed in your code that you are writing, then you call it. Okay, all right, so we can use we have functions with parameters as well. So you realize that in the other one that is at the top, there was no parameter. What I mean by parameter is inside the parentheses or the bracket in front of the greet, there's supposed to be some parameters, some items that will pass to it. All right, and the rule is that when you're calling a function that has parameters, you have to look at how many parameters are in this function. If you look at this function, I'm going to personalize a greeting and say that I'm defining a personalized greet that name, it will take name and time of the day, right? So what it's going to do is that it's going to print something, right? So here, this is what I want to do. I want to create a function that will print this. I want to greet someone, and I'm saying that I'm going to say good if it is even, and depending on what the user will do, right? Time of the day. I have to use whatever same parameter here, right? I have to make sure that if I'm going to use that parameter in this, I have to use exactly what I see there, time of day, and these things have underscores in them, so you have to be very careful about that. And I want to put your name, so maybe I want to say good evening, Alice, or whatever name you can think of. Okay, And then so I have this, right? Remember we use the f print here, which we've used it before. So here, if I run this code, it's Python now has knows what the function personalized greet means. Now if I call personalized greet, which is underscore greet here, and I want to use the name I'm going to use here is use this name, let's say AB, and I'm going to say evening. Let's see what happens first and run this. You're going to have issues because AB is not defined, and ideally we are supposed to use this, that, right? We are supposed to use because name and time of day are all strings, right? So if you just type it anyhow, you're gonna have issues, right? So good evening AB, right? If I want to use any other name, I can use some other name like Jacob or whatever you want to do. So you can use your name if you are typing this. You have good evening Jacob, and that is a personalized greeting that we've created. And remember, we use the define keyword to actually define our personalized greet, utilizing the parameters in Python functions. Okay, now we can look at, so all these things are just default things that when you create the function, it returns or it shows this thing, right? This is what we want to see. We want to print this to the surface or to the window when we call this function greet. Okay, now on the other hand, there are ways you can also define or say what you want Python to return, right? So the return statement gives you the chance to determine what should be printed on the screen after the function is called, right? So here I want to find a square of a number, right? Of course, the square here is a function name. When I pass on the number to that function, I want to return the number squared, right? And so I have to define what I'm supposed to return. Now I'm going to return number squared, and in Python number squared is being written as this, right? So if I run this, Python knows that this function, there's a function called square, right? And then if I pass a number, let's say 5 to it, I'm going to have 5 squared, which is 25, and this should give us 25. Indeed, we have it. Okay, so you decide what should be returned when the function square is being called. Okay, so here when I call square, together with a number that is being passed onto it, I have the number squared, right? You can go ahead and do another thing, function with docstrings. And here the docstring here is that you want to type a lot of comments. These are all comments, okay? And to have multiple comments in different lines, you have to use 3 quotations here and then 3 quotations closing, right? Then you can type all these things within or inside the 3 quotations that you've opened and closed. Okay, now what you have to, with a docstring, it gives you information about what is happening in that particular function. So you write a whole summary about what the function is about, so that people that are reading your code can understand what that function does. Okay, so here I'm saying that I'm defining a function called add numbers, and it takes 2 parameters a and b. So add 2 numbers and return the sum, right? So that's what this function is going to do. It will take the parameters a and b, which is either integer or float, the first number. B is either integer or float, the second number, and it returns integer or float, that is the sum of the 2 numbers, right? So here the return, what I'm going to say is that it should return a plus b, right? So that's the only thing we have to do here, just a plus b. So if I run this, it should keep it, right? And if I call this function called the add numbers, right, if I use a and b, I can say a is 4.5, it can be float or integer, and b is -10, right? So when I do that and run it, I'm going to have 4.5 plus -10, which is -5.5, right? If I change this line and do it like 50, and then that when I add 50 and -10, I'm supposed to have 40, right? I mean, that's what happens. So what function is trying to do here actually is trying to make sure that you, instead of you to type everything a plus b wherever you see some code, or maybe you want to add two numbers all the time in a very long code at different places, instead of you to come type the numbers manually, you can always create a function for that particular task, and when you get there you just call for that function and that would work for you. Okay, now lastly, let's work on this. Right, you're going to use factorial. If you use a calculator, you're going to see that there is a sign like this, the exclamation mark on it. If you type a number, let's say 5, and you put the exclamation mark, you should have 5 factorial. That should give you 125, I guess. Yeah, because it's going to be 120, I've forgotten, but let's say it's going to be 5 times 5. I'm doing 5 factorial now, and then 5 times 5 times 4 times 3 times 2 times 1, right? So that's what it means. And 4 times 3 times 2 is going to give you 24. 5 times 24 is going to be 120, I think. Yeah. So when you do 5 factorial, that's what you're supposed to get, 120. Yeah. If we want to use Python to create a factorial, we can actually write a function for it. And here, this is what it does. It calculates the, so this also has the docstring as well. Calculate the factorial of a number using recursion, and here the recursion will come at the latter part of the return. Parameters n, which is integer, non-negative integer, and so you have to make sure that your n here that you pass to this factorial function is non-negative, right? And then it returns integer, which is the factorial of the number. And like I said, if you want to see that on a calculator, you have to use n factorial, which is n exclamation mark on your calculator. Okay, now we have to pass on some if statement, because since n is non-negative, n can be 0 as well. But the way factorial is being defined, if you use the formal definition, when n is 0, you're going to have 0. But the basic definition for 0 factorial is 1. So if n is equal to 0, then return 1. Else, then return n times the same factorial function, but here we'll pass n minus 1 to it. So this is going to be recursion. So this is what is going to happen here in this line. You pick that n. Let's say if I pick 5, then I'll have 5 times factorial. So you go through all these process, and then the factorial of 5 minus 1, that's going to be 4. So I'll still get 4 here. I'll write what I'm trying to say here. So let me run this code first, and then maybe use it to find the factorial of 5, which should give us 120, right? That is true, right? Now this is what was happening. So 5 is the n here. So this last line here, right, is going to be, now first, if I have factorial 5, n is 5 now. So I'm going to have 5 times factorial n minus 1, right? 5 minus 1, so that's going to be 4 here, right? But factorial 4 should give us, that point n will be 4. 4 times factorial 4 minus 1, that will be 3. And factorial 3 will also give us 3 times 3 factorial 3 minus, which is factorial 2. That will be factorial 2 times factorial 1. And once you get to the point where you have 0, it will return 1. Okay, so then we'll have 120. Right, so this is what we have as the factorial of n. Now next lesson we'll talk more about more advanced features in the functions, and then we'll move to working with real data, which I'll share with you all. Okay, so stay tuned and don't forget to subscribe to my channel if you have not subscribed. See you in our next lesson.